Hello and welcome to How Do I BI. This is a mini-part screencast series on SQL Server Analysis Services 2008, which is designed as a companion to my book, Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, a developer evangelist with Microsoft in Southern California. In today's installment, we're going to take a look at using the BIDS built-in browsers to understand the data mining algorithms that are shipped as part of the AdventureWorks 2008 sample. Before we do that, we have some FAQs and gotchas. So under the FAQs, like the OLAP Cube samples, the data mining samples do not install by default. So I've recorded a previous screencast that explains how and where to get the samples and to install them, and I assume that you'll watch that prior to this screencast if you're not familiar. I'll remind you that the samples are edition, machine, and version specific. As with the OLAP Cube browser that's included with BIDS, the data mining browsers are designed for use by developers and administrators and not for end users. However, interestingly, these same viewers are shipped as part of some of our products, including Excel 2007, and are also available for as embeddable controls if you are an application developer. So these same viewers are available for use. Under gotchas, it's very similar to our gotchas when we were looking at the OLAP Cube sample. If you have some error when you go to browse, you're going to want to look at the data source connection defined in BIDS, and you're going to want to test that connection to validate that the server name, the username, and password credentials connecting back to the source AdventureWorks DW 2008 relational data is accessible. Also, as with the OLAP Cube, when you first open the sample in BIDS, you're going to have to process and build and deploy it so that that XMLA is available on the SSAS server. Before we go to our screencast, I'd like to highlight yet another community expert who's also one of the co-authors of the book referenced. His name is David Maury, and he is a SQL Server SSIS MVP, and you see that his blog is referenced on this slide as well. So now we're going to go ahead and go to the screencast. We're going to take a look at the sample data mining structures and models that are included with the AdventureWorks 2008 Business Intelligence sample. In order to do that, we're going to open Business Intelligence Development Studio, or BIDS, and then click on File, Open, Analysis Services Database. And in the Connect to Database dialog box under the Server section, we're going to put a dot to connect to localhost, and then select the AdventureWorks DW database and click OK. And what's happening now is the metadata, the XMLA, is being read into the BIDS viewers and browsers so that we can work with both the OLAP cubes and the data mining models. Data mining is implemented as part of SQL Server Analysis Services. So basically you get both OLAP cubes and data mining functionality. It is not required that you build an OLAP cube and then data mine that information. In other words, you can mine directly off of relational data. What I have found in production situations is that I generally prefer to mine OLAP data because it tends to be a little bit cleaner in terms of source data. So underneath Solution Explorer, we're going to navigate to the folder called Mining Structures, and we're going to see that we have 5 different sample mining structures included with our sample. We're going to take a look at the first one, which is called Targeted Mailing, and double-click it to load it into the designer in BIDS. As with the OLAP Cube, once we load this, we will see that there are several subtabs that we can work with, and these include Mining Structure, Mining Models, Mining Model Viewer, Mining Accuracy Chart, and Mining Model Prediction. Each mining structure contains multiple mining models, and in order to see that, if we click on the Mining Models tab for the Targeted Mailing mining structure, we'll see that we have had 1, 2, 3, 4 different mining models created against the source data, which happens to be relational. And these are shown by their algorithm names. So TM Decision Tree, TM Clustering, TM Naive Bayes, and TM Neural Net are the 4 different mining models. Each of these mining models process the data in a different way dependent on the underlying algorithm. If you're new to data mining or really trying to expand your knowledge of it, particularly for those of you who haven't had the benefit of a formal background in statistics at university, you'll probably want to start by clicking on the Mining Model Viewer. What happens in the mining model viewer is each of these mining models is loaded in one or more graphical viewers that can help you to better understand the results of your particular mining model. And you can see in the example that we've got coming up first that we have the TM decision tree algorithm being loaded, shown with the Microsoft Tree Viewer. And in this case, the tree viewer has actually two different views of the tree viewer itself. We have the decision tree, which is shown by default, which is a subtab, and then we have the dependency network, which we'll look at in just a second. So inside of the decision tree, what we're seeing is this data which relates to characteristics of customers who choose to purchase a bicycle. And for right now, we just have all data shown, and that's because the tree section has been set to bike buyer. If we click on the drop down, we'll see that's the particular attribute that we've selected. Underneath that, we have the ability to filter, and right now we've set it to all cases. What might be more meaningful for us is, rather than to see all particular cases, to see a particular state. So in this case, we're going to look at just those who have purchased a bike, and that's going to be state 1. Now you'll see that the shading on the tree viewer changed substantially here, and what this is showing you is, by number of cases, which attributes are most closely correlated with the bike buyer value being set to 1, in other words, people who bought bikes. So you can see that the most closely correlated attribute determined by the decision tree algorithm is the number of cars owned. Now the color has significance. If you click on one of the nodes, number of cars 0, you can see over to the right that we have a mining legend that tells us the number of cases that are associated with this particular state. Darker colors indicate a higher correlation. What becomes interesting is when we go beneath the top level node, which you could probably figure out just using common sense, that people buy bike depending on whether they have a car or not. For the situation of not owning any cars, the next most correlated attribute turns out to be where someone lives. And the strongest correlation is in the Pacific region. And we can see that indicated by color of node, by length of bar, and by the mining legend, and so on and so forth. If we look at number of cars owned equals 2, pass our mouse over it, we also get a tooltip to show us the case count. And then we can see the next most correlated attribute for this state value is the yearly income. Now this tree information might be meaningful to your end user, but it might be too complex or not in a state that would be useful for them. So we have another viewer shown here, and that's the dependency network. This is one of the most popular viewers because frankly it's very, very simple to understand. What we're showing here is for this attribute bike buyer, and if we click on it, you can see that the green indicates that it's selected, and the light orange indicates that all these particular attributes are predicting the likelihood of buying a bike in this particular case. What we then have to help us to make this information be more meaningful is this adjustable slider on the left, which is by default set to show all links. If we click and drag it, what happens is the attributes that are not as closely correlated fall away. And if we drag it towards the center, for example, we can see the attributes that have a greater likelihood of correlation for this state of a bike buyer. If we drag it all the way to the bottom, we can see that the most closely correlated attribute is the number of cars owned, which is the same value that we saw in the previous decision tree viewer, but it's a little bit different view in the dependency network viewer. If we click back up, we can see the next most closely correlated attribute is age and yearly income and so forth. This information can be extremely valuable in many different business situations, such as deciding where to market, deciding which customers to target, and so on and so forth. Now, if we wanted to see some of the other algorithms in the mining model viewer, we would go back up to the mining model viewer tab, the mining model section, and we would click on the drop down and adjust the decision tree to, for example, TM clustering. And if we do that, then we'll see that entirely different viewers load into the mining model viewer section in BIDS. So the first viewer that loads with clustering is the cluster viewer. And you can see again we've got that same slider at the left showing the correlation. Now this viewer is showing the clusters or groupings of data, and right now it's being shaded for the population. Now if we wanted to look again at bike buyer, we could just click bike buyer and we could see the shading for the bike buyer. Now this is set by default to a state of 0, which is people who haven't chosen to purchase bikes. And if we wanted to have kind of a similar comparison to what we just looked at, we'd set it to state 1. Now, these clusters, when we look at them, might not be incredibly meaningful because they don't have names on them. And it is quite common in production situations to give them more meaningful names, such as lives in a certain geographic area, has a certain age, or and so on and so forth. One way to discover more information about these particular clusters or groupings is to click on another viewer that's available here, which is called the cluster profiles. If we click on that, we can see that we've got a legend, in this case talking about age, and the very first attribute that we're looking at is age, and you can see for the entire population, here's the age of the source sample. So once we then look at the cluster 1, we can see that cluster 1 tends to have age information outside of the 40 to 58-year-olds that we're banding here. Cluster 3, for example, consists entirely of people who are younger than 35. Again, I recommend that you take the time to go through all the various cluster viewers as well as the decision tree viewers and all the other algorithm viewers, because it will really benefit you as you are understanding how to work with data mining and understanding how to present this information for your clients. Thank you.